So let's get started. I hope the board is pretty visible to all of you and my voice is loud and clear. We'll be taking up various methods of, calculating the rate constant of a first order reaction, where naturally the mother equation would be like K is equal to 2.303 by T log of A upon A minus X, where guess you all know A is the initial concentration and this is the amount left after time T. And we'll see various applications of the same. I'll want few people to respond. I hope my voice is loud and clear. We'll want to get started and I'll want to start with a question.
Yes, sir.
Yes, sir.
I want to start with a question. I tell you about a compound which is like CH3 whole twice CH N double bond N CH CH3 whole twice, which on heating is dissociating to nitrogen and C6H14. Nitrogen and C6H14. Nitrogen and C6H14. Suppose this is a problem given to you, and the values given are initial pressure and pressure at time t. So if it's first order kinetics, with P naught as initial pressure and PT as pressure at time t, you have to find K in terms of T, P naught and PT. So the question is, K is, and say the options are 2.303 by T log of P naught upon 2P naught minus PT, 2.303 by T log of P naught minus PT upon P naught. You have an option C, which is 2.303 by T log of P naught upon P naught minus PT, and you have an option D. You might choose not to write the option. You might not want to write the option. This being a real exam question, I'm writing the option, but you can very well do without writing the option. I'll give you a minute to attempt this question. I would want to believe, somebody can solve it without my help, and then I'm going to pitch in.
Sir, is it option A?
Yes.
Is it Nandini?
Yes, sir.
Sounds good. You told me you're unwell to attend the class today. I'll obviously give you the benefit of doubt, but if being unwell means, so being so good, you're doing good. Although I want you to get well soon. A indeed is the right option. A indeed is the right answer. I want more people, to tell me if you're getting A as the right answer, and we'll quickly move to the solution.
Yes, sir.
A. I have a few people, who are attending the class for the first time. Those who are attending the class for the first time online would want to come up with their name. Somebody attending the class from Rafi, I believe. I hope he is there in the loop.
Yes, sir.
All right, I can see you now. Have you done questions of this kind, Akshan? I hope I'm pronouncing your name all right.
Yes, sir. I've started chemical kinetics, so I have not covered up this topic, but I believe after explanation, I would be able to solve questions on it.
I'll still wait for a few more people to come up with the right answer. Nandini says A Agra, which is the right answer.
Sir, option A.
Tell me your name, please. You know, it always gives me a lot of happiness if I get to know the name of the student giving me the right answer. So after Nandini, I heard it from.
Sorry.
Yes. Yes, please. All right. So let me, let me. I hope I'm being understood. I can give you the solution right now, I believe. Let me give you a similar situation when instead of the real equation, I would rather want to write, suppose a situation like A gaseous becoming B plus C. I think this is the situation, this is the analogous situation. A gaseous compound, dissociating into two gaseous compounds. The ratio is 1:1:1. Now at time t is equal to 0, if the corresponding pressure is P naught, at time t is equal to T, temperature, volume remaining constant, the amount obviously is proportional to pressure if it's all gaseous. Yes or no? I think I'm being heard. Pt has to be proportional to P naught minus X plus X plus X, which is Pt being proportional to P naught plus X, and this will give me X being proportional to Pt minus P naught. Yes or no? तो चलो हाँ ना बोलो.
Yes, sir.
And now, when I have to write for K is equal to 2.303 by T log of A upon A minus X, I'll believe that A is proportional to P naught. I'll believe that A is proportional to P naught any day, and A minus X will be proportional to P naught minus Pt minus P naught. If X is proportional to Pt minus P naught, please respond with a yes or no.
Yes, sir.
And this is how I'm going to solve questions of this kind. I would not be using any data in today's class. I'll be giving you expressions only. If the problem is loaded with data, you can obviously do the needful. But this is P naught, and A minus X being proportional to P naught minus Pt minus P naught. This is going to look like 2P naught minus Pt. I hope you're all there with me. This is option A, I reckon. That's the right option. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Akshan, you can understand me? Rest of you? You can take a snapshot if you want.
Yes, sir.
And now everything else remaining the same. Give me K in terms of T, P naught and Pt for a reaction like A becoming 2B plus C. Come on, I'll give you a couple of minutes to do this. Give me the value of K in terms of P naught and Pt, where yet again P naught is at time t is equal to 0 and Pt is at time t is equal to t. So you have to kind of give me this expression. I'll give you a couple of minutes to do this. Go ahead.
सर 2 P0 by 3 P0 minus PT आ रहा है क्या?
अरे हाँ यार, एकदम बिल्कुल परफेक्ट आ रहा है। तू बोल रहा है तो गलत थोड़ी होगा। अच्छा बच्चा है तू यार। ऐसे ही मैं थोड़ी देर को चौधरी जी बोलता हूँ। So because somebody has already spilled the beans, Reyes tells me it's 2p naught by 3p naught by minus pt.
Yes, sir.
Yes, sir. All right. I think I can give you the solution right now. Or I still want to give you a minute. I'll still want to give you a minute. In a real problem, what can also happen is for different T, they'll give you different PT. Naturally, P naught will be a constant for a given reaction. For a given system, for a given setup, P naught will be a constant. For different PT, for different T, they can give you different PT. And by experimental data of different PT at different time intervals for 2-3 intervals, if you get the same value of K, this could also be a way of proving that it's first order kinetic. अलग अलग डेटा पे अगर K का वैल्यू कांस्टेंट आता है, I'll just feed the value and I'll prove that, it's the first order kinetics. They can give you some problems of that kind when the time is right. But we'll want to move on. Just I've given you enough time. And now, in this problem, which is say question 2 for today, for question 2, if it is A becoming 2B plus C, this will become 2x plus x, and naturally this will become P naught minus x plus 2x. X will get cancelled out, which will mean x is proportional to Pt minus P naught by 2. Yes or no? बच्चे लोग हाँ ना बोलो.
Yes, sir.
Any day A is proportional to P naught, like it's going to be always the case. Initial amount, is the corresponding pressure, and here A minus x will be proportional to P naught minus Pt minus 2 by Pt minus P naught by 2, which will mean it's proportional to, now 2P naught plus P naught will be 3P naught minus Pt by 2. So when you substitute this value, this will get you an expression of this kind. बच्चे लोग हाँ ना बोलो.
Yes, sir.
Now let me tell you another question, which is based on a dissociation of this kind. I guess we can move to the next screen. You have a problem which is N2O5 becoming 2NO2 plus half O2. Where both N2O5 and NO2 are soluble in chloroform. This naturally is the gaseous form, which is insoluble in CHCl3. It's first order kinetics. And you have to prove that in terms of volume of the gas, which is oxygen, I hope I am being understood. If this V naught is volume of oxygen at time t is equal to 0, and Vt is volume of oxygen at time t is equal to T, and V infinity is volume of oxygen, naturally when reaction is over, when you say infinite time, It means when all of N2O5 are dissociated, you have to prove that K is equal to 2.303 by T log of V infinity minus V naught upon V infinity minus Vt. Now, trust me, this is going to be a very interesting ratio. V infinity minus V naught upon V infinity minus Vt is going to be a very interesting ratio. See if you can prove it. It's like a system where this is happening. It's like a system where this is happening. And 205 is breaking into 2NO2 plus half O2. And you know, we have kept CHCl3 here. If you have kept CHCl3 here, if you have kept CHCl3 here, it's only the volume of oxygen which is relevant. And naturally, this piston will be moving up. With oxygen gas being produced, the volume would be increasing. Got me? You can obviously believe this to be zero. You can obviously believe this to be zero. I'll give you a minute to give it a try, cell patient. I hope my voice is loud and clear, and I hope you're trying. I want you to get used to V infinity minus V naught by V infinity minus Vt. In this case, V naught is certainly zero, but you know, I want you to get used to this expression. Should I give it a try? It's simple.
Sir,
Now suppose, yes please, has somebody got it?
yes sir. पूरा जो N2O5 का नंबर ऑफ मोल्स था वो पूरा कन्वर्ट हो जाएगा V इंफिनिटी पे, तो A/2 O2 बन जाएगा, और V infinity will be directly proportional to A/2 और VT will be directly proportional to X/2. तो अपने को A minus X चाहिए, तो A/2 minus X/2 करेंगे तो आ जाएगा.
Yes बोल रहे हैं क्या? Yes बोल रहे हो क्या? The last man to enter the class, is it you?
हाँ सर.
So obviously I believe if it is the volume of oxygen at the time of the reaction getting over and this is zero, you believe, you know, I'll always believe that V naught, V infinity minus V naught upon V infinity minus Vt can obviously be written as, finally, if the volume is in terms of the initial concentration A by 2 minus 0 upon, if this is V infinity, which is A by 2 minus X by 2, I hope you're getting me, it will be as good as A upon E minus X. Yes or no? बच्चे लोग हाँ ना बोलो.
Yes, sir.
I want you to get used to the V infinity minus V naught upon V infinity minus Vt form, because this is what is going to, be relevant in problems involving data of this kind. If you're happy with this, we'll want to move to a very coveted question, which so many people keep on asking me in the offline, online class at times. I'm kind of clobbered with this particular question, which is optical rotation of sucrose to glucose and fructose. I've spoken a bit about this. So this situation which is inversion of sugar, which is about C12H20O11. Instead of writing the formula and all, let me write sucrose becoming glucose plus fructose. And the very name of this reaction being inversion and the enzyme used being inverted, I've told you, because this plus 66.5 degree and this plus 52.5 degree and this minus 92.4 degree. Please pardon me if I make a mistake with a few degrees here and there. Is eventually something dextro and an equimolar of dextro and levio, eventually becoming, levio-rotatory, is about as this reaction progresses, a dextro solution becomes levio. Now, generally the data at hand is, suppose a theta naught, which is the rotation, optical rotation at time t is equal to 0, a theta t, which is the optical rotation at time t is equal to t, and a theta infinity, which is rotation at time t is equal to infinite. And again, what you need to prove is, again, this being a first order kinetics implied, k is equal to 2.303 by t log of V naught minus, V infinity minus V naught upon V infinity minus Vt. I'm going to solve this for you, don't worry. I'm going to solve this for you. See, more often than not, you'll need to apply this formula only, which I want to be, pretty monotonous in terms of infinity minus, oh my God, I've written V here. I've got used to V. I've got used to V. It's going to be theta. Certainly, it's going to be theta. So I think the problem at hand is understood. Sucrose, which was dextrotated to begin with, gives you 1 mole of glucose and 1 mole of fructose. Eventually, something dextro becoming levio. Is the reason why you call this process inversion. The sugar is also called invertase is the name of the enzyme. I'm going to talk about the chemistry behind it when the time is right. इसको invert sugar बोलते हैं, invertase बोलते हैं enzyme, but inversion का मतलब यही है. Should I go ahead with the explanation part? I would want a few people to respond. Lecturer,
Yes, sir.
yes, I can move on. Now, again, instead of sucrose, glucose, fructose, allow me to write A becoming B plus C, where this is chiral, and this is chiral. I hope I'm being understood. The rotation, because of any particular species, could be written as its specific rotation. Now, what is the specific rotation? The specific rotation of a substance is a particular value when you have the parameters like unit concentration, unit length of the tube, and if this is the specific rotation into the amount of A, the concentration of A at that instant of time into the length of the tube. See, this is how the total optical rotation would be obtained. Naturally, this is a specific rotation, which is the rotation per unit concentration per unit length. Yes or no? So I can write this for RAAL, RBBL, RCCL, and the corresponding rotation for the mixture of chiral compounds. And trust me, again, this being proportional to the concentration at time t is equal to 0, if you have A amount of this to begin with, and at time t is equal to t, if it goes by x and this forms x and this forms x, and at time t is equal to infinity, if you believe that this is getting over, and certainly this is giving you A and this is giving you A, बच्चे लोग हाँ ना बोलते रहो. बच्चे लोग हाँ ना बोलते रहो.
हाँ सर.
Theta naught is the rotation because of only A. And let me write this as RA into A. I'll assume L is constant throughout, so it's again a term which is ruled out. I'll write theta T as when you have RA A minus X, RBX, and RCX. If these are the corresponding specific rotation, the amount of B and C is in terms of X. And I write at infinite time, the total rotation is when naturally this has become 0, this has become 0. So this is equal to RBA and RCA. Not hard to believe. See, I'll have to eventually project K in terms of theta naught, theta t. Naturally, keeping in mind that it's eventually 2.303 by t log of A upon A minus X. So A upon A minus X would bear a look like theta infinity minus theta naught upon theta infinity minus theta t. Yes or no?
Yes, sir.
Now, this is a term which you'll want to get used to. This is a term, which is generally going to be given in terms of numbers in the real exam. And all you need to do is, be good with this particular ratio. I'm simply going to prove that theta infinity minus theta naught is going to be A common RB plus RC minus RA. And theta infinity minus theta t, again, I'll write it initially in the formal manner, RBA plus RCA minus RA, A minus X, plus RB, X, plus RC, X, and this is a negative, yes or no?
Yes, sir.
And now what I can do is, I can write this as A minus X common. Suppose if I take A minus X common, I hope I'm being understood. You'll have RA with a negative term. I can obviously write this as RBA minus RBX, RBA minus RBX. And if I take A minus X common, it will be RB positive, RCA minus RCX. So if I take A minus X common, it will be RC positive, and I have A minus X with a negative RA, so this will be minus RA. Yes or no?
Yes, sir.
And now I think it's pretty visible. If I do theta infinity minus theta naught upon theta infinity minus theta t, it will be eventually a upon a minus x. It will be upon a upon a minus x. Yes or no?
Yes.
So what I'm trying to inculcate is you getting used to this equation more often than not. The data will be there in the problem. You can take a snapshot. You can ask a doubt if and when it's required, but get used to theta infinity minus theta naught upon theta infinity minus theta t. And when the time is right, you'll also understand that in case of optical rotation, this will be independent of the stoichiometry. Trust me, this will be independent of the stoichiometry. Even if it's a becoming 2b plus c, I can prove that the value of theta infinity theta naught is going to be used in the same conventional formulae. For the time being, let's focus on inversion of sugar only. But trust me, it will be irrespective of the stoichiometric coefficient. I hope it's fairly visible. You can take a screenshot right now. I think it's fairly visible with the entire data in one place. Get used to theta infinity minus theta naught upon theta infinity minus theta t. ठीक है बच्चे लोग? Just we can move on.
Yes, sir.
Next is say acid catalyzed hydration of ester. So you have an ester in presence of H plus and water is becoming an acid plus alcohol. It's taken a pseudo order reaction where naturally you'll see the rate of the reaction, will be equal to K concentration of ester only. Naturally, water is an excess, it's aqueous medium, and the role of H plus is catalytic. Because the role of H plus is catalytic, the amount of H plus will remain practically constant. H plus being catalytic, the amount of H plus will remain catalytic, being constant, and you have water acting as the medium as well. So this is in excess. ठीक है? लोग हाँ ना बोलो.
हाँ सर.
अब एक रिएक्शन है जिसमें इस एस्टर में मैं HCl और वाटर डाला हूं जिससे ये एसिड और अल्कोहल बन रहा है. at different intervals, I'm drawing a fixed volume, I'm drawing a VML of the sample, and I'm making it react with a volume of NaOH. I'm titrating it with a value of titrated with a given volume of NaOH. At time t is equal to 0, the volume of NaOH required is V naught. At time t is equal to t, the volume of NaOH required is Vt. And at time is equal to, again, this basically means when the reaction is over. When the reaction is over, it is V infinity. Yet again, you have to prove that K is equal to 2.303 by T log of, see, I want this idea to be ensconced. V infinity minus V naught upon V infinity minus Vt. Please take it down. I hope you're understanding the story. ये mechanism पढ़ाऊंगा organic chemistry में when the time is right, but you understand something which is being catalyzed by an acid, the amount of acid will not change. So because the amount of acid will remain practically throughout the process, it would not change. So it's obviously going to be constant throughout. Water being excess in aqueous medium, rate is equal to K Easter is the first order kinetics. बच्चे लोग हाँ ना बोलो. A given volume of the mixture at different intervals is being titrated with NaOH. You're drawing a particular volume of the sample at constant intervals. I told you, this is not only going to be a way of finding K at different time intervals, if they give you different values of T, naturally for a given experiment, V naught and Vt will remain, V naught and V infinity will remain same. And Vt will be different for different time intervals. For different time intervals, at different time intervals, the different volumes of NaOH required to neutralize it. And with different equations, if you get the same value of K, this will be like a proof that it's first order kinetic. I hope I'm being understood. But chalo, हाँ ना बोलो.
हाँ सर.
हाँ सर.
So let me arrive at this result again. And this time, because it's acid catalyzed, I need to be a little careful. I need to understand if it's an ester which is becoming acid plus alcohol over a period of time. At time t is equal to 0, ये A था. At time t is equal to t, ये x गया तो ये x बना और ये x बना. And at time t is equal to infinity, you understand? This is becoming 0. तो ये पूरा का पूरा A बन गया, yes or no? The catch in the problem is यहाँ पर पहले से भी एसिड है. बिकॉज यहाँ पर पहले से भी एसिड है, यहाँ पर V नॉट 0 नहीं होगा. यहाँ पर सपोज यू हैव H प्लस which is some B moles. I think I'm being understood. ये कांस्टेंट रहता है, ये B moles कांस्टेंट रहता है थ्रू आउट. कैटालिटिक रिएक्शन है, एसिड कैटलाइज है, तो B moles कांस्टेंट रहता है. So I believe कि this V naught is proportional to B. हाँ ना बोलते रहो. Vt at any instant of time, which is the volume of alkali required at different time intervals, will be equal to proportional to B plus X, क्योंकि एसिड यहाँ पर X बन गया है. And allow me to write V infinity being proportional to B plus A. All we have to now prove is V infinity minus V naught upon V infinity minus Vt is A upon A minus X. Yes, I can do that. So even for acid catalyzed hydration of ester, even for acid catalyzed hydration of ester, you will want to stick to this mother equation. I think I'm being understood. बच्चे लोग हाँ ना बोलो.
हाँ सर.
अब you have to play around with a few things. You have to play around with a few things. यहाँ पर V infinity minus V naught is generally going to be positive. ये positive positive होता है. Let me just tell you a particular fact. ये पहले copy कर लो फिर मैं बताता हूँ.
सर यहाँ पे V नॉट डायरेक्टली प्रोपोर्शनल टू V कैसे आया था?
मतलब मेरा शुरू से ही तो इतना एसिड है ना. मेरा तो शुरू में एसिड और HCl और वाटर जब डाल दिया हूँ तो इतना तो मेरा कांस्टेंट है. ये तो कैटालिटिक एसिड कैटालाइज्ड है. X प्लस तो मेरा थ्रू कांस्टेंट रहेगा. तो मैं शुरू में जो B डाला हूँ शुरू में V नॉट तो जीरो होगा नहीं. The alkali is reacting with only acid. So initially the acid in the mixture is B.
ठीक है सर, थैंक यू.
That B is remaining constant. Over a period of time, if acid formed is X, this is remaining constant. तो पूरा सैंपल नहीं लेके जा रहा है. सैंपल का थोड़ा सा एलिक्विड लेके जा रहा है. तो taking a small sample of the total reaction mixture. Yes or no? I hope I'm being understood.
यस सर.
I keep it simple. In physical chemistry, most of the times I'm going to keep it very simple. What otherwise could be obtained in a more complicated manner, I see diagrammatic approaches to things and much more complicated approach to all of it. I would keep it simple. It's eventually going to be very, very student friendly in all of physical chemistry. थीटा इन्फिनिटी माइनस थीटा नॉट अपॉन थीटा इन्फिनिटी माइनस थीटा टी. कभी कभी क्या होता है ना, ये मान लो नेगेटिव आ रहा है तो कभी कभी क्या होगा, थीटा इन्फिनिटी नेगेटिव होगा. ये नेगेटिव वैल्यू रहेगा. तो कभी कभी ना ऑल्सो ये नेगेटिव नेगेटिव भी कैंसिल हो जाता है. अगर इसकी जगह कभी ऐसा लिखा रहे कि k is equal to 2.303 by t log of, you get used to this and then again this would not bother you. अगर ये ऐसा भी लिखा रहे, the ratio will remain the same. Yes or no? So be mentally prepared for something of this kind as well. Theta infinity minus theta naught upon theta infinity minus theta t, or theta t minus theta infinity upon theta t minus theta infinity, the ratio is going to remain the same. Yes or no? I just wanted to add this so that you don't get confused if you have a ratio like this discussed. ठीक है बच्चे लोग? बच्चे लोग हाँ ना बोलो.
हाँ सर.
ये भी मेरे को लगता है कॉपी हो गया सबका. ऐसे स्क्रीनशॉट ले सकते हैं वन. ऐसे स्क्रीनशॉट ले सकते हो. Another very common first order reaction is decomposition of H2O2. Decomposition of H2O2. So when it comes to decomposition of H2O2, H2O2 becoming H2O plus half O2 at different time intervals, this H2O2 is titrated with K-4. This is also a spontaneous reaction and all of H2O2 will get dissociated. At some point of time, I do tell you H2O2 is an oxidizing agent and peroxides are unstable and all of this will get dissociated and in a period of time we'll have only oxygen left. That is why you have a strength of unit called volume strength for H2O2, which is the volume of oxygen available per unit volume of the sample. H2O2 का सैंपल को ऐसे थोड़ा सा कफ सिरप के जैसे हिला दोगे तो पूरा डिसोसिएट करते हैं. अलग अलग टाइम इंटरवल पर एट टाइम t is equal to 0, एट टाइम t is equal to 0, अगर वॉल्यूम ऑफ K-4 required to titrate a given sample of H2O2 is V naught, and at time t is equal to t if it's Vt, and at time t is equal to infinity, when you again believe all of this reaction has got over, if this is V infinity, again I can prove K is equal to 2.303 by t log of V infinity minus V naught upon V infinity minus Vt. So I get used to this form. Now there's amount of K-4 which is titrating with H2O2. Remember the amount of K-4 which will be titrating with K-4, the amount of K-4 which will be titrating with H2O2 at time t is equal to 0 will be proportional to the initial amount. This will be proportional to amount left at that time. And if all of this has got over, V infinity here will be 0. Yes or no? तो चलो हाँ ना बोलो.
Yes, sir.
And this is where you know the value of V infinity will be 0 because all of H2 would have got over by now. You know V infinity will be 0 and V naught will be a value which will be of initial amount of H2O2. You know this ratio is as good as, this ratio is as good as, this ratio is as good as V naught minus V infinity upon Vt minus V infinity. Yes or no? So you have to understand that I'm going to stick to one particular form and I'll be applying it in the reverse as per the reaction or the situation in the problem. ठीक है बच्चे लोग?
हाँ सर.
Achha, another development is I might be taking the class tomorrow. Tomorrow, Howrah, I might be taking the class, and you know, in tomorrow's class, instead of starting a new topic, I would discuss a few nuances of nuclear chemistry, ठीक है? Carbon dating, uranium dating, कोई first applications of first order of kinetics. तो ना न्यूक्लियर केमिस्ट्री का जो कोर्सेज है बिकॉज मैं ही कल क्लास ले रहा हूँ वो मैं कल की क्लास में कर लूंगा इन वन क्लास इट विल बी एनफ टाइम और जब रेडियो एक्टिविटी पढ़ा रहा हूँ न्यूक्लियर केमिस्ट्री पढ़ा रहा हूँ दैट इज द बेस्ट टाइम टू टॉक अबाउट पैरेलल एंड सीक्वेंशियल इक्वेशन रिएक्शन तो ये सब मैं कल की क्लास में करा दूंगा कल ऑफलाइन क्लास में लाइव करवा दूंगा तो सी पीपल टुमारो इन द लाइव क्लास एंड again, you know, in the online mode, I don't want to carry on for another 1 hour or so. If I start nuclear chemistry or radioactivity, it would take me at least 1 hour, if not more. So let me do it in the live offline class tomorrow, and I'll seek your leave for the time being. ठीक है बच्चे लोग? Stay happy, stay healthy. Thanks for attending the class. God bless you all. Bye bye. Take care. Good night. मिलते हैं.
Thank you, sir.
Thank you sir.
अब ये सारा वैल्यूज ना V infinity, V naught, Vt ये सब प्रॉब्लम में दिया रहेगा. Once you learn the tricks of the trade, वो वैल्यू पुट करके आंसर निकालना बिल्कुल सही होगी. ठीक है दोस्त? Take care everyone. Bye bye. Good night.